Making your way in the world today takes everything you've got. Taking a break from all your worries sure would help a lot. Wouldn't you like to get away? Sometimes you wanna go.
Gosh, it's bright. Hello, everybody. Thank you for making some time to see this presentation. Let everybody settle down. Interesting stuff from the last presenter about battery life and signal and so forth. Quite a lot of it's very pertinent to what you're going to see here, actually. So, okay. You've heard about smart cities endlessly, right? So, we thought we'd come up with a different name. We had actually started with the idea of smart village. I live in Derbyshire in the UK, in a very, very rural part of Derbyshire. It's actually a national park. And so the project you're about to see came about in the last couple of years. If I press this button, there we go. Right, so that's a really bad, I didn't realize the screen would be so big. That's a really grainy image, I'm sorry about that, but roughly speaking, those are some of the highlights of the area I live in, along with, 15,000 other people. This area here is actually the valley area that's being referred to in the name. So as you can see, it's very scenic, it's very rural. We've got a bit of 4G problems, but yeah, it's iffy, but other than that, yeah, there's lots of spaces with no connectivity, and you're miles from any power or anything like that. So that's a little summary on the Peak Park, which is the context for this project. And I should emphasize here, this is very much a grassroots type project, right? So I didn't come into this with a lot of knowledge or having a lot of money behind the project or a lot of expertise. I literally jumped into this feet first. So you'll see there's been some mistakes, but quite a lot of learning and education that's come out of it. So this is the background. I won't read that out to you, but basically the principle is that we're trying to gather more data on the flows of people in and out of the park. And there are huge numbers that come in and out of the park, and they have a significant impact. Actually, just as a matter of interest, has anybody ever been to the Peak Park in Derbyshire? Yes, okay, very good. One person, right? Well, there's a lot of people in and out of the area. It is very much an attraction. We began to see a huge surge in people after the COVID lockdowns, or even during them to some degree. And we began to, and I say we, I'm referring to myself as a member of a parish council, some other parish councillors, some other knowledgeable people who were interested in the rural community and so forth, and trying to develop a bit more of an understanding of what was going on in the park. I keep standing out of the way, but of course you can see that anyway, so I'll turn around, and there it is. So, yeah, a highlight at the bottom, the project still in technical development, data gathering ongoing, outline of technology and experiences to date. So that's kind of where we started out, right? And I know I'm rambling a bit, but I think you get the general picture. And these are some of our stakeholders. So it's fairly broad-based, and everybody's got a very different perspective on what the park and the area means to them. But when you get many millions of people every year coming into the park and many hundreds of thousands in and out of the valley, there's a real impact on the overall quality of life within the valley and also the experience of people those visiting. So our first project was to put an air quality network in. I say that very casually. Has anybody run into the sensor community? Anybody here? Okay. Well, a sensor community is a kind of a cool thing where you can deploy these very cheap air quality sensors and hook them up to Wi-Fi, and they pop up on this map. And then you can look at charts to see your air quality. The sensors typically measure 10 micron and 2 micron particles, I think. And then you can look at activity over time. It's a worldwide community, so you can zoom into any part of the world. You'll find these sensors are up and active. The color of the sensors tells you roughly the quality of the air at that time in that place. So we put this up, and it was, turned out to have a lot of uses, a lot of interest from people. And we do have some polluters in the park that we're very conscious of. I won't go into detail on that, but this data has proven to be very useful in figuring out where some of these pollution sources are. Okay. So following up from that, we thought that it would be really handy now to develop this kind of citizen science idea and find a way to develop better information about the actual flows of people in the park. So the lower paragraph there, that explains the old-fashioned way of doing it, right? And that was all about having people go out with counters and literally count people on the roads or in the car parks. Really, really poor data, very inaccurate, very unreliable.
So trying to watch the monitor there instead of with your back to the...
Yes, I'm sorry. You're absolutely right. I'm making a terrible mess of it. So here we go. So our intent was really to try and create something that mapped a little bit the way the community, the sensor community worked, but to use that as a way of visualizing the flow of people in and out of the park. So there's a sample of what the air quality sensors look like in the current instance, and you can see some of the major features of the valley there. We've got the towns marked out on the railway line. So the very first thing, as you all know, if you're deploying LoRa, you need gateways, right? Fortunately, one of the active people on the project runs a wireless deployment company and was able to put gateways up for us. So here we've got a sort of an image of, roughly speaking, how we got gateways into key parts of the valley. Hope you like my graphics. They're not great, but they generally tell the story. So we got these up, and these are connected to the Wi-Fi backhaul. So these are now basically covering the whole of the valley area. That was the first part. The next part was to develop the sensors. So this is an interesting thing. There's a GitHub repository that carries something called a PAX counter. Has anybody run into that? Okay, yeah. So it's a pretty cool piece of code. Basically, it uses the BLE and Wi-Fi sensors on the board to count how many unique MACs that it sees in a period of a scan. And it takes that count and then transmits it via LoRa. So by setting the scan rate, you can effectively begin to create a picture for the movement of people in and out of an area. Deployment of these sensors with a flashed version of the PAX counter is pretty straightforward. We figured out how to do it. As a result, we had a fairly accurate sensor, and the only other thing was to come up with a way to power it, because in those locations, obviously, we've got very little access to any reliable power sources. We settled on these standard battery packs. We're using 2650s, I think, 26650 cells, yeah. These are actually good to run the cells for up to 5 weeks, or sorry, the sensor for about 5 weeks. And as a result, when they're on a 10-minute cycle, we can actually get quite a good stream of data. Let me look at yeah. So as you can see, we took a very low-tech approach to our sensor enclosures. Those are literally Tupperware boxes that have been slightly modified. We did try the high-tech approach of fake rocks. They don't actually look too good in the wild. The peeling paint tends to give them away. So, but yeah, that was our initial instance of getting them out there. What does the architecture look like? So I'm sure everybody in this room has run into some of these things. We needed a database. We wanted to be able to do the mapping piece that I referred to earlier. We also wanted to be able to send alerts. So playing around with all of these requirements, the architecture you can see there emerged after some time. The key part to that actually is we're using Node-RED And I imagine quite a few people here have run into this. If you haven't, it's a really cool product. It's open source, fairly easy to figure out. It's, you know, for people like me who don't really know anything, you can more or less figure out how to make a flow. A quick show of hands, how many people are using Node-RED for an IoT deployment? 1, 2, okay, 3 people, right, I'm surprised. It's ideal, I think, for these time series deployments. The other piece to this, obviously, we use the MQTT interface to TTN. Seems to be pretty reliable. Mostly there's enough diagnostics. If you've got problems connecting, it you know, seems to be easy to figure out. I mentioned the gateways, and I've talked about the sensor. So that's roughly the architecture from a flow perspective. And there it is with all the bits thrown in. Those are the actual pieces that we used. One interesting extra element is we incorporated the Met Office weather data into the data stream, into Node-RED, and that gave us an ability to begin to correlate movements of people and patterns of people and activity with weather patterns. So all of that flows into Node-RED. And then we've got Influx sitting on the other side. We had a lot of help, by the way, from the Influx team. They've been really good. We're using something called Leaflet, which is the mapping feature, and just simply integrated with a Gmail account for the alerts. So having picked our locations and built up this infrastructure, you can see a sort of summary image of what we've actually got now functioning. We actually had 8 or 9 of these sensors around the valley, but as we've now come out of the season, we've just let some of them expire, and we're down to 3 of them that we keep running in the main parts of interest. So within each of these nodes, there's a color-coded, like a hotspot function. So the nodes change color, and then you can drill down and get a map based on the data stream for the last day or week or 30 days, so forth. We've had to spend a bit of time focusing on battery life. Josh, who was speaking earlier, highlighted some really important elements of how you can maximize battery life. We've learned quite a bit about that. We've also had to deal with insects. Insects are a bit of a problem. Many of our locations are in, you know, shrubs and bits of grass and what have you. You know, they're not ideal because obviously nature isn't made to accommodate IoT sensors, but we do what we can. Okay, then there's an alerting capability that we've built, which not only helps us with the operational side, but also we do use it to give us an indication of high rates of flow in certain locations. But the slide there just points to the operational support, so we're able to get alerts on low battery conditions, or if a device goes offline. And then I saw earlier today that the Things platform has now got gateway management tools emerging. It's actually really interesting because we had actually started to build some of those. Because in our case, if a gateway goes off, it might be the only one that a sensor can see, so then we lose 1 or more sensors depending. And then it interrupts the data stream. So what do we get in terms of data? So there's a typical pattern for one of our locations. So, you know, it kind of looks like what you'd expect. It's only when you drill into the detail that you begin to see some interesting patterns. And then if you lay on weather, now you can actually start to see correlations between flows of data, flows of people and weather patterns. And we've now got this for over a year's worth of activity within the valley area. And it's the kind of data that is now drawing quite a lot of interest from some of the larger community bodies who, they have questions, but they've never been able to get answers to them. You know, like, what's our busiest day? Are we busier at Easter? Are we busier on the bank holidays? You know, all this stuff. Nobody really knows, but we can answer these questions now. We say, yeah, it's really busy at 9 a.m. on Easter or whatever, you know. Or you may say that certain locations are busier on certain days than other locations, and this is why, because you can correlate them. There's a lot of really good answers that you can deduce from the data here. As you can see, it's quite variable. There are other elements of this which are quite interesting. You know, there are times when there is activity in what are supposed to be areas that have restricted access, but there's often activity in them at times you wouldn't expect. That's actually been of interest to the National Trust, who manage some quite sensitive areas of the landscape. So let's talk about some of the more geeky stuff. I'll try and answer any questions at the end of this. So it's a rural location, right? So we often have problems with sensors going offline, not able to reach a gateway going down. So this is an early attempt to find a sort of a diagnostic way to figure out if we could use the periodicity, is that correct? I think the intervals anyway, between data being sent to the gateways so that we could begin to see if a sensor was having difficulty making a connection. I believe there's actually an interesting function within the influx database, which we're using for this, which allows us to create these patterns based on the period of time between data cycles. As you can see there's some sort of irregularities in the pattern. It looks a bit like a train track with a couple of sleepers missing, right? And that can be quite indicative. These ones look reasonably okay, but there are other cases where it's actually very indicative and it helps us understand what's going on. So signal strength. So this is the kind of stuff I think we're seeing on the new gateway management tools that are appearing in TTN, but we tried to build these out in the initial instance. So the top one's just a scatter graph. So the different colors are actually the different gateways that our sensors are hitting, and then we simply record the signal to noise, and what that does is it gives us a very good indication of what's going on. I seem to have lost the video here, but that's okay. It's a bit fuzzy, but I think you get the picture. The bottom histogram is, what that does is it tells you which sensor is having the most difficulty connecting. The more to the left it is, then the more difficulty that sensor is having. So you can see there's actually quite a wide variation. The histogram turns out to be quite a good way to track this. And these are all built into Influx, by the way, into the notebooks. And then this is data relating to gateways. Again, it's pretty simple stuff, but it's all helped us keep track of what's going on. And the right-hand one actually is for battery packs. So we can tell if we've got battery packs or problems, or indeed when it's time to swap them out. So, what are we doing next? We've got a couple of things on tap on the technical side. It's really interesting coming here because I can see a lot of new functionality appearing in the TTN platform that obviously is going to preclude us having to spend time developing it, so that's really good. Solar is definitely of interest for us. We're outdoors. We don't always have the capacity to find a place where we'll get clear access to the sun or to the sky, but it's definitely of interest. Sensor management using uplink features, that's absolutely on the cards as well. And then from the data perspective, now that we have almost a year's worth of data, we can start to develop really interesting profiles of activity around people movements on those sites. That actually is really where we're heading for next, because that's kind of the point of the project, right? So, you know, we've got a couple of ideas in terms of where that's going to go. Nothing firm yet. And then the final point there, being able to share this data with key stakeholders in the park. For example, the Peak Park. You know, if they're able to indicate to you at 9:30 a.m. that it would be a bad idea to go to MAM Tour today because it's always really busy, and it's already really busy, or, you know, somebody else might want to be able to inform people that, you know, that the railway station is really busy today. There might be a flood of people into the village for shopping purposes or what have you. All this information is actually really good to have in real time, and it's very typically the kind of thing we've all learned about with smart cities and so forth. There we go. I think I just made 0 on there, so I think I've hit my mark. I presume that's what that was. Little bit of info there. Questions? Anybody got any questions? Right. Okay. Well, that went over well. Good. Very pleased. I hope the presentation was of interest to you. I'll be around if you have any other questions. But thank you all very much.
Closing doors. Oh, when you're flying high, just know